Hello students, this is the third lecture of control system. In the last lecture I have discussed about the types of control system, and the two major types I have told that one is open loop control system and another is closed loop control system. I have already discussed about the open loop control system along with some real life examples in the last lecture. In this lecture I will be discussing about the closed loop control system with some real life examples. Now the closed loop control system is basically two types. One is manually controlled and another is automatic controlled. Now in this first short, I will be discussing about the manually controlled system, where let us start with a real life example of manually controlled system that will help you better understand the working of the system. This is the automobile drive system, where steering mechanism is also introduced, and this is absolutely manually controlled because the car or the vehicle is driven by a driver. So this is the basic block diagram, where the desired course of travel, since it is a steering wheel mechanism is also included in this system, so therefore the desired course of travel is important for the vehicle. That means the direction in which the vehicle is intended to move, that is set as a reference, that is set as a benchmark here. And that benchmark, following that benchmark, the intention of the working of the system is to always follow that particular set direction of travel. So for that, in the rest of the blocks, here you can see the driver is sitting over here, who is working on this steering, and that's why here it is steering mechanism is shown in this block. And that will be driving the system, which is the plant or the process in the diagram, that is the automobile. And that automobile is going as per the direction given by the driver through his steering. The vehicle is moving in the particular course of travel, and so this is the actual course of travel. Now up to this, when desired course, the driver, the steering mechanism, the automobile, the actual course of travel through this path, which is called the forward path in this diagram, is absolutely in open loop. There is nothing, the loop is not created. That means this is just a path, and this is the forward path where the driver is driving the vehicle simply that in the desired direction. Now, if the system wants, or someone wants, that whether actually as per the desired course of travel the vehicle is moving or not, for that the loop has to be introduced. That means the system is to be converted into a closed loop. For that, first we should do that from the actual course of travel, which is the output of this automobile, a sample is taken, that is provided into this block. The sample is taken from here, from this position it is taken. So this is the position from where the sample is taken from the output, and that is given to this measurement visual and tactile block. The meaning of tactile is the body movement of the driver. That means according to the body movement, the vehicle is supposed to move in that particular direction. That is called the tactile movement. And also the visual movement is in the actual direction the driver will see that the vehicle will go once he is changing the direction of his steering. So this measurement of visual and tactile block, what it will do, it will take the output sample, and that will be provided to a particular device. This device, which is nothing but a comparator here. Because why it is called a comparator, or why comparator is selected for this purpose? It is because the desired course of travel and the actual course of travel, these two data needs to be compared. And that comparison can be done with a device which is called comparator. That is why the feedback signal is put in this comparator shown as minus, and the desired course is shown as plus. And these two will be compared by this device, and this device will give the decision, will give the output that whether actual, as per the desired course of travel, actually the vehicle is moving or not, or it is moving in some unintended direction. So this is basically, now if this is the forward path, this is called the feedback path, because from the actual course of travel, the feedback has been taken and it has been put into the inside input side or the desired course of travel side of the diagram, and so this path is just working in the opposite direction of the previous path, which is termed as the forward path. Now this is basically the block diagram for the body movement and the driver's vision that will be driving the actual course of travel of the vehicle. Now there is another part in this diagram, that is the steering wheel sensor, that has been put as a block over here, and this steering wheel sensor will always, after this block, the output of the steering mechanism, it will be just tapped from here through this steering wheel sensor, and that will be provided to this comparator block. So this comparator block will actually compare two things. One is desired course of travel, and as per the visual and tactile movement of the driver, whether the vehicle is moving in the proper direction or not, through this comparison, through these two paths, and through these two paths there will be a second comparison whether the steering wheel sensor, which is providing the direction of the travel of the steering data of the vehicle's movement data, that is provided through the other path. This is the second feedback path that is also provided in the comparator. So this comparator is getting two feedback paths, and both the feedbacks being compared with this desired course, that means the reference. So this is basically nothing but the manually controlled closed loop systems, real life example, very common example. Another common example we can cite, that is in a traffic crossing, when it is a red green combination of traffic signals is being set. If we do not consider the rate of traffic flow through the crossing, then I have told in the last class that then that will be the open loop system. But if we want to convert that traffic light signal crossing into a closed loop system, then we have to consider the rate of traffic flow in either direction of the junction. And that rate of traffic flow, if that is incorporated in the control system of the traffic lights, that is red or green, that means in the direction where the traffic flow is more, it is supposed to have the green light for more length of time, and in the direction where the number of traffic is less, the green light will be glowed for lesser amount of time. So based on this logic, accordingly the timer will be set in either direction, and also this setting of the timer is enhanced, is supported by the feedback from the output. That means how much traffic is moving in either direction through the crossing for a certain period of time. So that can be also considered as a real life example for a closed loop system which is manually controlled, and that traffic light controller can be controlled by a traffic police sitting over the crossing, or later on it can be converted into an automatic system as well. So now, considering this manual system, there are some limitations, and because of these limitations, later on this manually controlled system has been shifted to automatic control system. So what are those limitations? Let us first see. First, if we are having a complex system, we need to work with a complex system or a fast responsive system. The skill and the ability of the human is utmost important. So therefore, if the human who is operating that system, who is driving that system manually, is not that much skilled, that means for a fast responsive system, for a very complex system, the human intervention to work with that system has become really difficult. For that case, we need to shift to other type of closed loop control system, and that is automatic control system. The other two important factors are human safety and economics. That means if we involve a person for a long period of time to operate a closed loop control system, we need to think about his safety always, and also we need to think about how much we have to pay for to that person, how much we have to pay to that person for that particular job. So all these four different features are absolute limitations for manually controlled closed loop system. So that's why we need to shift to the automatically controlled closed loop system. So from this diagram, we just convert this diagram into a generic automatically controlled closed loop system, which is shown over here. What we are seeing over here, this diagram has been modified into this. Here, this comparator with this desired course is shown here. This is the comparator, the same thing which I have shown in the last diagram, in that diagram. And this is the reference input given with a plus sign over here. And this comparator is basically getting the feedback like in the previous diagram from this controlled output. Now this controlled output is giving this feedback through a block which is feedback path elements. Previously I have told that it is measurement, visual and tactile from this diagram. Now this is nothing but feedback path element here. So this feedback is given to this comparator, and this comparator will compare the actual course of travel or actual output, that is the controlled output, with this reference input. If there is a difference between the two, immediately an error will come. That will be called error. The difference between the reference input or the command input and the actual controlled output, that will be called an error. That's why this device which is comparing and giving us this error, computing this error, is called basically an error detector. So this comparator is working as an error detector in this system. Now this error, or else it will be called actuating signal. Actuating, I have told in the last class what is the meaning of actuation. That is, if error comes, it will immediately trigger the rest of the system to work in particular directed fashion. So this error or this actuating signal will be given to will be used as the input to this control element block. Now what are these control elements? Control elements, here you can see this driver, this steering mechanism, etc. As if we compare these two diagrams. And this automobile is basically the plant and the process. Here in this diagram, this is shown over here as plant. So therefore, this diagram is just converted into a diagram to show that manually controlled system is just, it can be transitioned into an automatically controlled system with this generic diagram. Now if we want to give a solution for a control problem developing from this diagram, we need to select two things basically. The controlled output sensor, that means with what sensor we will be sensing the sample of the controlled output so that it can be fed back to the error detector to compare with the desired desired output. So this is the desired output which is set as reference input, and that desired output is compared with the controlled output with a sensor. So the selection of the sensor to solve a control problem is important. And another thing, the plant which will be driven by this actuating signal from the controller part, that actuating signal, that controller's output or the actuating signal is another important thing that will determine what type of controller we should use to design this system. So this sensor and this controller are the two integral parts, most important parts to design a control system. So once they are selected, thereafter just giving the different parametric values, we need to develop first a mathematical model. So this reference input is a time domain parameter R. It is denoted by R. I have already told in the last class. This is denoted by R, which is a time varying variable, so R of t, and the error that is being generated after the comparison of this desired output and the reference input, that will be, or the desired output and the actual output, that will be compared to give the error signal that is denoted by E of t. So this is also a time varying signal. This is the actuating signal, and that will be giving the control element the required command what it should be doing with the plant, with the working of the plant. That means whatever variation the plant is facing in its different working parameters, that variation from its ideal set value that gap need to be closed, that gap need to be minimized. That is the control objective of working with this automatic control system. So that gap, that means the desired and the actual, the gap between the two, working with different parameters of the plant, we need to minimize more and more with the time. So this plant will be working on that output signal from this controller or the control element, that is U of t, denoted by U of t, and that will be processed out to give the controlled output, which is denoted by C of t. So once this R of t, E of t, U of t and C of t, everything is given, now from this C of t, from any instant, we can select any instantaneous value with the help of a feedback sensor. Out of C of t, some signal is being fed into the feedback path elements, and that will be giving another signal, which is the feedback signal, into this error detector, denoted by B of t. That means R of t, E of t, U of t, C of t and B of t are different parametric values, time varying parametric values that will be used for mathematical modeling finally of this system. So once that mathematical model is ready, after that the controller design part will start with the required simulation, and through different iterative steps, once the simulation is okay, then finally the hardware prototype of the system can be developed. So this is the way how a control problem solution can be derived. So this is the basic generic block diagram of automatic closed loop system, or generally a closed loop system, and this block diagram will be used in the due course to study the different other aspects of control system. Now, before I conclude, what is the final objectives of working with this diagram or with this system, with this closed loop system? Number one is disturbance reduction. Now, what is disturbance? Disturbance can be encountered through this block plant. So this is disturbance input. So this is the main thing, one of the main thing which will be disturbing the different plant parameters. That means the parameter of the plant which we need to control, that can be disturbed by any external unwanted signal. So this plant will be getting an input which can be termed as disturbance input. This disturbance input reduction is of primary focus. We need to develop such a system so that minimum disturbance can affect the working of the plant. Now the second is steady state error reduction. Now what is steady state error? Steady state error is, the error is basically E of t. It is in time domain. This is nothing but this reference signal R of t, which is connected with a plus sign, and a B of t is coming back through this feedback path with a minus sign. So R of t minus B of t is basically E of t. Now this E of t is basically a time varying signal. Now as time will move on, that means if we limit the time up to infinity and check at that point what is my value of E of t, that will give us the value of error, which is called steady state error. So steady state error means when t, time, is tending to infinity, it is having a very large value, and if we want to observe at that point of time how much error is there in this system, that can be termed as the steady state error of the system. And that steady state error, so in this equation, if we put a limit with t tends to infinity, we can compute this ESS, that means the steady state error. Now the idea of working with the closed loop control system is absolutely to reduce this steady state error. Now this steady state error is nothing but the desired and the actual, the difference between the two. And the control objective is always to minimize as much as that gap possible. Now the third and fourth is of this objective is transient and frequency response. So these are the ways, these are the avenues with which we can by doing transient response and frequency response, we can analyze absolutely the proper working of any closed loop control system. And number 4 is sensitivity to parameter changes. That means whatever the design parameters, selected for working of this closed loop control system, whether the errors is coming in the design parameters or the selected parameters or not, that parameter changes how much it is sensitive to external disturbances, internal disturbances, load disturbances, etc. So how much any particular selected parameter which is under scanner, which is under control, is called the sensitivity of parameter changes. If it is for a small change of those disturbances, if the actual working parameter of the system of the plant of the system is changed quickly, that means it is highly sensitive. If it changes less quickly, then it is lowly sensitive. So therefore, sensitivity of parameter changes of the plant, that is very important to design, to understand, to analyze the proper working of the closed loop control system. So this is all about what I can tell, I can explain to you, I can analyze with you that how the closed loop control system in manually controlled form and automatically controlled form can work. I hope you have understand. Thank you for watching and listening.